Yeah, g'day YouTubers, Tinker O'Toole again here with another video on chainsaw geometry. We've done it before, so we're going to go a little bit more in depth. We'll talk about first the names on certain parts of a chainsaw tooth. So if we look at a chainsaw tooth, this represents a full chisel chain with a sharp point. This is the most aggressive, but because of the sharp point, it dulls a little bit quicker. So the first part we refer to is at the back of the tooth, which is referred to the heel, and the front is referred to the toe. The top of the cutting tooth is referred to the top plate, and the side of the tooth is referred to the side plate. The top plate, it's got a compounded beveled angle, so this angle on the front of the tooth here is referred to the top plate cutting angle. So this is the angle that it goes down on, and it's normally about 60 degrees on most teeth. So that's the top plate cutting angle, not to be confused with the top plate. Then you've got the rivet hole where my thumb is. Then down the bottom of the tooth, that is what we refer to the gullet. This is referred to the depth gauge or raker, whichever way you want to call it. The other thing is you've also got the tie strap, that is referred to the tie strap there, and that's referred to the drive link. And this section underneath the tooth, this is where a lot of the chips get evacuated. Some do come out of the side. It depends on, as the chain is going through, cutting through, a lot of the chips will come out the back, and the moment that the chain clears the log, what chips that are trapped in there come out through the side or out the back. So that's pretty much it, the different parts of them. And what we'll do is go into an explanation of this angle here, and we can vary that angle, so we'll go into that, and we can also vary this angle here, and we can also vary this angle on the side plate. So we've got three angles that we can vary: the top plate angle, the top plate cutting angle, and the side plate angle. So we'll go into that. With those angles that I was talking about, there are a couple of ways of maintaining those angles. One is by using files, and the other way is by using I've got a Stihl USG grinder, and USG stands for Universal Sharpening Grinder. It does hedge trimmers, circular saws, and chainsaws. The dial at the front moves the chain from 0 degrees to the desired angle that you want, left and right, because a chain has a left tooth and a right tooth. When viewing a chain's left tooth and right tooth, it's always viewed from the back of the chain. So if you're using a chainsaw and you want to set this top plate angle here, that is done on this scale here. Now, because the tooth has a compounded beveled angle, and that simply means that you've got an angle on top, which is the top plate angle here, and you've got the beveled angle, which is here on the front of the tooth. Now that's at 60 degrees. So the grinding wheel will come in at 60 degrees, or if you're doing it by file, and the file is held roughly about 20% above the top of the tooth there, that'll also give you an angle of 60 degrees. To obtain that 60 degree angle, you adjust this tilting head, the grinding head where the grinding wheel is, that tilts to the correct position, and 9 times out of 10 it will be at 60 degrees. That's on an Oregon type grinder, and on this type of grinder, the Stihl USG, it's slightly a little bit different. It's 30 degrees. Now the reason it's 30 degrees is because Stihl use 0 degrees reference point, so we move over 30 degrees. On an Oregon, we use 90 degrees as reference point and we move over to 60 degrees, which means that we only move 30 degrees from the center line. Exactly the same thing, different reference point. So 2 angles, it's 3 angles really. Your top plate angle here, which is usually 25 or 30 degrees, we'll get into that. And the top plate cutting angle, which is the angle that the grinding wheel or the file comes in. And if you're using a file, yes, it definitely has an effect on the C shape. And if you're using a grinding wheel, depends on the profile, it should follow the same pattern, which is a C shape like that. Now there's another word that you may come across, and you'll hear the word kerf. Kerf simply refers to the width of the groove that the tooth makes in the wood. So a smaller chain would have a narrower kerf. So if we go to a very small chain, 1/4 inch, it's got a narrower kerf than say a 3/8 chain. So we'll just briefly talk about the different chain sizes that are out there and the different gauge sizes, because that's all part of geometry as well. You've got 1/4 inch and 1/4 inch low profile, which is, or they might call it 1/4 inch micro. Typically they use that on the smallest of saws, even the handheld pruner. I've got a Stihl GTA 25, I think it is. So all those little battery operated hand pruners, they run generally 1/4 inch Pico chain. So, and you've got normal 1/4 inch chain, which is very small. Then you've got 3/8 low profile chain. So again, the tooth gets slightly bigger. Then you jump to 0.325. 0.325 comes in 3 gauges. It comes in 50 thou, 58 thou, and 63 thou. So again, the kerf is getting bigger. Then we go to 3/8. Now the kerf on 3/8, the actual width of the tooth is 4.5 millimeters in width. And a hexa in a 3/8 chain has a narrower kerf, and the width of that is 4.1 millimeters. So that's interesting. So there are narrow curved chains in the same size. Then the largest and widest tooth of all is the 404, which has the widest kerf of all. So that's your different chain sizes. And in your different chain sizes, you've got your different drive link widths. So they come in 1.1 millimeter width, 1.3 millimeter width, 1.5 millimeter width, and 1.6. Now typically 1.6 millimeter width will be on a 3/8 chain. So your 3/8 low profile will have a 1.1 millimeter drive link width. So it's just a matter of all the different saws out there range from small saws to large saws. If you're an arborist and you're in the top of a tree and you're cutting the canopy out, you don't need a big saw. You want a reasonably powerful saw, but you want a lightweight saw. And that's one of the reasons that you've got different bar sizes, the width of the drive links, the different length of the bar, and the different types of chains. So you can mix and match what you want if you're a professional. Now, the other thing is, when we talk about, so we've spoken about the narrower kerfs. Now, typically there's 2 chains that I can tell you off the top of my head, which are Husqvarna's X-Cut. It has a more narrower kerf than the standard chain, and we've got the Hexa in the Stihl range. Now, there's 2 types of teeth, and we haven't discussed those, the semi-chisel and the full chisel. Now, your semi-chisel chain has a working corner that's got that nice rounded edge there. Look at that nice rounded edge, that curvature on here. So this is referred to the working corner. Normally, this angle here is 30 degrees. You can have 25 degrees, but 30 degrees is a little bit more aggressive and it works quite well. People have been trying these angles for many, many years. So, you know, you're not going to reinvent the wheel making your own angles up. Your full chisel. Your full chisel is square shoulder, no rounded corner on that. Comes to a very sharp point and it's easily damaged. The moment it gets damaged, it won't cut very good. But it generally cuts between 10 and 15% faster than the semi-chisel. And it has an angle here of 25 degrees, which is good for hardwood. You can put 30 degrees on this if you're using softwood. But generally speaking, it's recommended that you put 25 degrees. The top plate cutting angle on here, whether it be file or whether it be grinder, should be around the 60 degree mark. Yes, you can lean it over and get more aggressive, and the more aggressive that you go, things don't generally last as long. You have to resharpen more often. So typically, if you look at the Stihl semi-chisel, it's got 60 degrees entry going on there. It's got 30 degrees on here on your semi-chisel. Your full chisel, same thing. You've got 25 degrees here and 60 degrees going down on the face. Hexa is 65 degrees going down on here and 25 degrees on the face. Husqvarna's X-Cut is even more aggressive. It's 45 degree angle on the top plate cutting angle. And I actually haven't measured it, but I would assume that it's probably 25 degrees on the top plate there. A milling chain. Well, a milling chain doesn't cut across the timber. It's designed to cut with the timber, and you don't have big aggressive angles on a milling chain. Generally, they could be anywhere from 15 to 10% on the top plate angle. So that's that part of that there. So we've spoken about the narrow kerfs, we've spoken about the different gauges, and we've spoken about we haven't spoken about file size. Now, files come in different sizes: 4mm, 4.8, 5.2 and 5.5. So if you've got a small chain like a 3/8 low profile, you use a 4mm file. If you've got a 0.325 chain, you'll use a 4.8mm file. If you've got a 3/8 chain, standard 3/8, you can either use a 5.2mm file, which is recommended by Stihl. Other manufacturers recommend a 5.5mm file. Also, a 404 chain uses a 5.5mm file. So you've got those different file ranges there. So that's a bit about the geometry. Generally speaking, when you buy a chain that's suitable for the type of wood that you're going to cut. Now, we spoke about the full chisel and we spoke about the semi-chisel. Where do you use the semi-chisel and where do you use the full chisel? Where do you use the Hexa-cut? First of all, Hexa-cut was developed for the forestry industry. According to Stihl, they designed it for people in the forestry industry. I don't know whether that means they use them for harvesters or whether that means that they use them for hand cut. In either case, you can use it for both, I guess. So that's the Hexa. We'll put that aside because that's fairly new. It has only been out about 3 or 4 years. The semi-chisel, which is a bit like the chipper chain that Joseph Cox invented back in the 50s. The semi-chisel chain, 95% of chains out there would be running semi-chisel. It is your best chain that's going to get you out of all sorts of trouble. Even if you've got a log that's got termite ridden, there's a little bit of dirt in it. A semi-chisel can handle a little bit of dirt. It will go blunt, but a full chisel is more aggressive, and if a full chisel hits dirt, it'll go blunt even quicker. A full chisel can cut between 10 and 15% more than a semi-chisel. Hexa can cut up to 20% more than a semi-chisel. And roughly, Hexa will cut about 10% more than a full chisel. even though that it is a full chisel, but the hexa has that hexagonal profile. It looks like that. Now, interesting enough, when we look at the standard side plate, it looks like a C shape. I've done a lot of experiments, and this type of shape here is very, very interesting on the hexa. What I will say about all these different angles and shapes is a lot of them only give 5-10% difference in performance. I guess hexa is a bit of a more of a game changer. Semi-chisel and full chisel is a bit of a game changer, but some of the angles that you put on them, when we're talking about 25 degrees and 30 degrees, yes, you could use 30 degrees instead of 25. How much difference is it going to make in your cutting? Look, it's only going to give a few percent difference. It's not going to be a major game changer. So, you know, if you turn around and run 30 degrees on your semi-chisel in hardwood, the worst thing that can happen is that it's probably going to dull a little bit quicker. It's really not going to make any difference if you cut in firewood. Where it makes a big, huge difference is to people, professionals that are cutting big, huge trees, got big, massive, long bars and using MS-880s or something like that there. That is where it is critical, and that's where it makes a huge difference. So everything that I've shown you here is not going to have any dramatic effect on what you do in your daily routine, cutting limbs off trees or cutting small trees up to, say, 1 foot or 2 foot in diameter. Now, there's another subject that we haven't gone into any detail, and it's probably one of the most important of all, and that's the depth gauge or raker gauge and the attack angle. Because if you don't have the attack angle set right, it won't cut wood properly. It's pretty much that simple. Now, for those that don't know what attack angle is in metal work, it's in woodwork, and quite simply, the attack angle is this angle here. From this point of the tip of the raker to the point of the tooth is regarded as attack angle. As the tooth comes around on the bottom of the saw, it has this very slight rocking motion, and when the tooth touches the timber, it pushes down. The raker touches the timber and prohibits it from biting any more. So that is your attack angle there. And during the rotation of the motor, it'll pull a chip out, go along, and it'll do the next on the next one. So it has this little motion. So attack angle. This attack angle on a brand new tooth, so we've got one here. That's a brand new tooth there. That attack angle there is about 5.5. The degrees. And we measure that with this type of gauge here. This is called a digital angle gauge. So when you turn it, it changes angles. And if this was sitting horizontal and we place it on top, we end up with an angle. Hence the name digital angle gauge. So a tooth that's brand new could be 5.5 degrees attack angle. The ideal angle is about 6.3, but nonetheless 5.5, 5.3 is still quite good. Using this type of raker gauge, and I'm sure you should know how to use one of these when it's placed over the top of the chain. Anything that protrudes out this gap is filed flat. Unfortunately, when we look at a tooth and you look at the gap on a brand new tooth, this gap from the raker to the point of the tooth is around about 6 millimeters. But by the time we get to the end of the life of the tooth, which is here, way back here, you're looking at about 12 millimeters. Now, yes, the raker does go down, but this type of gauge here will not give you a good attack angle of around 5.5. By the time you get to the end of the life, you'll be lucky if you're 3.5. An attack angle of 3.5 is very poor cutting efficiency, because what's going to happen, it's going to look like this. The distance between here and here is quite big, and you've got a very poor attack angle. So look at that attack angle there, and have a look at the attack angle here. You can see how steeper this is. So to maintain a correct attack angle, in 1968, a man by Ray Carlton invented the progressive depth gauge and put a worldwide patent on it. This sits on one tooth. These little legs sit on the tie straps of the tooth in front of it. The raker protrudes through here, and you run the file over the top. This has got a Rockwell hardness of about 62, which is harder than a file. So you don't have to take it off and file. You sit it on top and file straight over the top. It's got a hard set-in and a soft set-in. It will maintain an attack angle of at least 5.5 from being brand new to the end of the life. So your attack angle will look like this when you get down to here. Now, this type of gauge is called a constant depth gauge because it will only ever keep a depth of 0.65 of a millimeter from brand new to the end of life. So you can imagine when the gap gets about 12 millimeters from here to here, and we're worn down right down to the end there. This rocking motion works different. The attack angle is no longer in the right area. It's around 3.5. It's going to cut very, very poorly. How many times have I heard someone said, my chain's half worn out, it doesn't cut like what it used to. It actually should cut better. The reason that it should cut better is because the actual tooth is on a taper. It's got a taper. So by the time you get down to the end of the life, and you're to measure with a digital vernier, if this is 4.5 millimeters in width here it's probably 4 millimeters. It's a narrower kerf. So the kerf gets smaller as the tooth wears down, and it will cut more. So, yeah, provided you're using this type of depth gauge. So when we spoke about all angles before, and we spoke about semi-chisel being 30 degrees on the top plate angle. So top plate angle on a semi-chisel being 25 degrees, sorry, 30 degrees on semi-chisel and 25 degrees on full chisel. That's neither here nor there if you're using this type of gauge, because that type, as I said earlier in the piece, a couple of degrees here or there is not a game changer. But certainly using this type of gauge compared to this type of gauge is a game changer. This starts off at 100% efficiency and probably goes down to about 60% efficiency. This starts off, and this is from brand new to end of life, down to the witness mark that's on the tooth. So that's what we're talking about. The efficiency of this gauge starts off at 100%. By the time you get down to here, you'd be lucky if it's 60%. Now, this type of gauge starts off at 100%, which is 6.5 millimeters. In depth, by the time it gets down to the end of the life, that has increased from 0.65 of a millimeter to about 1.2 millimeters in depth. Almost double. Because it has to do that to maintain the attack angle of, well, it's about 5.5. So attack angle is in everything. If you look at a metal lathe and it's spinning around and they put their bit in, If they put the bit in the wrong angle, especially in stainless steel, it'll start to chatter and jump around. Even in woodwork, you've got to have the woodworking chisel. As the lathe is rotating around, you put the chisel at the right angle and you get a beautiful finish. So attack angle is critical in a lot of things, in metalwork and in woodwork, and it is no different on a chainsaw chain. It's just something that we started using, these flat gauges that were invented and patented by Joseph Burford Cox in Portland, Oregon. And once people start using something, they are very reluctant to change. And that's exactly what happened through our history in the last 60 years. And it wasn't until 1968 that Ray Carlton invented these. Still have only brought these out since about 2017. This is one from Husqvarna. So this is a progressive depth gauge as well. It's not as aggressive. I've actually made my own. There's software that you can do, software available on the internet where you can make your own gauges. So I've made my own. Also, what's very interesting about different angles, before we spoke about top plate angles and top plate cutting angles, different wood can require different angles too. That's a bit of a preference. So if you're a professional, eventually you'll find out that if you're cutting really hard wood and it's dense, that you may prefer 25 degrees over 30 degrees. And if you're cutting soft wood, you prefer 30 degrees. Your top plate cutting angle, you might want to go more aggressive. You might, instead of being 60 degrees, you might want to go 55. You might want to go 50. This is all personal preference. Especially the professionals, they will do what's best for them. Anyway, that's probably about as much as what I can say. That's probably the last part in the tooth geometry. The best thing that I can say in wrapping up is do yourself a favour. Go down to your local steel dealer, get yourself a progressive depth gauge. Not one gauge fits all, same as this gauge. This particular gauge here will fit 1/4 inch, 3/8, 0.325 and 3/8 pico. This is chain specific, so there's 5 gauges out there: FL1, FL2, FL3, FL4, FL5. This is FL4, 3/8 standard profile. FL5 for 404, and FL1 for 1/4 inch chain, and FL2 for 3/8 chain low profile, and FL3 for 0.325. So if, especially people in America, for some reason still don't sell these in America, go to West Coast Saws there in America. They've got their own, or go to Husqvarna. Husqvarna sell these. You should be able to get these in America from Husqvarna. There's 2 different versions. This is a roller guide as well, so you can get you can get them just in the actual raker without that roller guide. That's a dual combination type one. Look, I hope this information helps, but just remember, do yourself a favour. It'll be, you'll thank me for it. Get yourself a progressive depth gauge and you'll thank me for it. Thanks for watching. Bye for now.